So I'm sorry about that confusing quiz at the end of last week. I forgot. Normally I do one final example in my hybrid class, and this particular section I actually do the intro because I like having the back and forth in the conversation of the start of 6.2. So I'm going to try to do that as best I can without a back and forth, without you guys here to discuss it with me as we look at section 2, confidence intervals for a single proportion. So the first exercise just really is supposed to get around this idea of why an interval is necessary. So first question I ask students is, what's the proportion of students that are left-handed? If you had to guess, right, just sort of an off-the-wall guess. So usually classes land somewhere around 15–20%. So let's just say 15%. And then we have the idea that, well, if we really don't know, we're just doing this completely based on opinion and what little knowledge we have, maybe we should go take a sample. And if we took a sample of 10 people, well, of 100 people, and found that 19 were left-handed, we might amend this estimate. We might now say, well, our p-hat, our estimate from this sample is 19 out of 100. It's just 19%. And so we could use that 19% to estimate the real thing. And in fact, I guess we should put a hat on the first one because it's also an estimate. And then we keep going. We say, okay, what if we took a sample of 1,000 students and found that 165 were left-handed? And again, we could find another sample proportion, another estimate of our real value for the proportion of students who are left-handed. And so this seems like a really silly activity, but it has two big takeaways. The idea here is, one, the first big takeaway is if we want to estimate a true value, estimate a parameter, we're going to just use the statistic. We're going to go out and take a sample. So if we want to know about the population, a sample is going to do that. And if we want to have this estimate of whatever it might be, whether it's a mean or a standard deviation or a proportion, we're just going to use the sample value to do that. So that's the first important idea. The second important idea is, well, the question, which of these is the best of the estimates, right? We have one that was just based on opinion, we have one that's based on a sample, and then we have one that's based on an even bigger sample. And that gets us to the second idea, which is the more information we have equals a better estimate, right? And that's an important idea, and it seems very basic and very obvious, but this is probably our best guesstimate because it has the largest sample size. We feel that this is probably similar. And if we actually think about why, it goes back to that sampling distribution, right? If we are taking samples, they should be close to the real value. So this one doesn't count because we were guessing. But in the other two, we were taking samples. They should be close to the real value, but the bigger our sample size, the smaller the standard deviation, the harder it is to get away from that mean that we're clustered near.